Hey guys, and welcome back to the Sylvania Halolight restoration project. This is part 3. First two parts, the set arrived, took a first look at it, tested the picture tube, reviewed the chassis, and at one point I concluded that it was going to be difficult to work on because it appeared that the various components were hardwired together. In other words, they installed the components, ran wires, and soldered them directly to various points, and it was going to be difficult to pull them out and separate them to work on it. Turns out that's not exactly the case. This lower chassis is very easy to get out. There are two plugs on here. It looked like conventional tube sockets that had plugs with wires coming out of them, one going to the yoke, one going to the upper chassis. High voltage output going to the CRT, and there was a strap going to, I think, the tuner area. You disconnect that stuff and it just comes right out. And it sits on these insulating fiber boards on the end here. And there's a note on here saying one side of this chassis is going to the AC line and the AC interlock is right over here. This is most definitely a hot chassis. I think some of the other parts are floating, but there is a strap that goes from this to the upper part. So you definitely need to be careful working on this. And I suspect it's very important to reconnect that strap. Now the upper part, yeah, that looks more complicated. So there's a big circuit board up there, there's a tuner on this side, there's some other stuff over here, but I think that whole assembly pulls out as one piece, and I think you can work on the circuit board in place without having to detach it and disconnect the wires, because that is hardwired in, but I think it's meant to come out as an assembly and you just deal with it and service with the board mounted to the frame. But this we can work on. It's a nice little isolated module here. So this is the one that had that goofy cap floating on top, and it has a big filament dropper resistor here. We got some tubes. This is the sweep board. So a horizontal output tube here, damper tube. I think that's the vertical oscillator and output there. It's mounted on this little wobbly socket here. It's to isolate it from vibrations from the speakers, I imagine. That's it. Inside here we'll have the high voltage rectifier. We'll take a look at that. Enough to fly back will be in there. There's some controls here, some controls here, little things sticking out here. It looks like there could be a control here, but I don't see any evidence that there ever was one. Oh, I see, that's a circuit breaker. Okay, I saw in the schematic that there was one, but I wasn't sure where it was located. I thought it'd be accessible from the back, but I think that's it. It's a Fusetron. Okay. Wouldn't be surprised if that was bad. Alright, so now the big reveal. What is under this? What construction technique they did? And we know the IF and the video output audio, that's on a circuit board, but what's under here? Are you ready? Here we go. Whoa. I was wondering where the rest of the electrolytics were. I saw there was a little stubby one on the upper board and one on top of this. That is the largest multi-section paper cap I've ever seen. So, no twist locks to be had in this set, which I suppose makes it a bit easier to work on. But, man, that is huge, and that is nasty and crusty, and oh, I'm sure it's bad. Got a couple sprig atoms that have been tacked in here, so I'll just add to the fun. We'll have to trace stuff out. I'm guessing that's a filter choke. Oh yes, so somebody worked on this at some point, maybe in the 80s or something like that. I'll have to look for some date codes, because originally there were some big old honking selenium rectifiers here, and they've been replaced with a terminal strip and 2 diodes. This was done some time ago. And they replaced, I'm going to guess this replaces some of these, but they obviously left this in place. And we got all these wax paper caps down here that need to go. And the cap, that's probably the death cap. The cap is going across the AC line right there. Goofy looking coil there. Big old power resistor right next to it. And yeah, there's a mess on this end of gooey waxy caps. So obviously no circuit boards or anything like that. Good old point-to-point wiring on terminal strips. And just, I haven't seen anything mounted quite like this before. Well, you can see why it came loose, because I think there's just one screw that holds it in, because these, there's just these, it just sits there in the cabinet. There's a hole, there's a slot cut, and this goes into it. And there should be one screw here that holds it down, but it appears that's it. Unless something broke off, which is possible, but it's not obvious because this side doesn't have anything, so how could one little screw hold all this in place? Well, speaking of screws, looks like we have one screw here. If we take that out, we'll be able to see what's inside this. 1/4-inch sheet metal screw, as usual. Kind of hinged. What's this come? Oh, I see. It's got some slots here. You just slide it over a little bit and it lifts right out. And dinky little flyback. And good old 1G3, I imagine. Flyback looks okay. Not fantastic, but it's burned up or anything. Use a little touch up on the coating there. But yeah. Be very careful when I take this off so I don't break that off. That is a small flyback, that's for sure. I did print out some service info. So I found this, and it's very confusing because one of the SAMs that this is in is folder 472 and the other is folder 427, so I've been endlessly confusing myself. I printed out the newer one, the 472, which I know doesn't match this perfectly. They talk about a 23-inch CRT and whatnot, but this stuff seemed to match. Oh, it's a horizontal multi-vibrator down here, not the vertical. Wait a minute, didn't that tube chart say it was the... Well, the tube chart that was on here says it's the 10DE7 vertical output. This service info says it's the 6CG7 horizontal multi-vibrator, which honestly would make more sense to me. So, what is it? It is a 10DE7 vertical output tube. So where the heck is the 6CG7 horizontal oscillator and output? Is that on the top board? That doesn't make sense. Why wouldn't you have it down here? Because it just directly drives this guy. Goofy. Let's see. Yeah, it is up there. Yeah. It's right next to the sound output and the video amp. Go figure. I would have put it down here if I was designing this. We deal with what we have, which means, yeah, the service info is not going to be very helpful for working on this, so I'll have to print out the older one. It's coming back to haunt me what I read online of the only other guy I could find who was trying to work on one of these. Said Sam's doesn't seem to have the right service info. If you look up this model in Sam's, they say to use this. But I mean, we got a huge problem immediately when they got a different tube here. Unless that's the mistake, I'll take a look at the parts locator and see if that matches. But, it would have been nice if nobody had worked on this, because then, well, you can just replace what you see, if you can read the values on it, and just replace that with a new part with the same ratings. But if somebody's tinkered with it, thought I printed out the lower chassis, the upper chassis locator. Let me see what I got. Oh, there it is. Certainly similar looking. There's that giant cap. There's the two selenium rectifiers I mentioned. A little hard to read. orientated the same way. Yeah, they show this being mounted 45 degrees rotated from what I have. That's similar. It looks like it's close enough to make you think that it's right, but it's not a perfect match. Well, crap. Now, at least these look all original. I can start replacing these wax caps. When it gets to working on this stuff, I'm going to have to be a little more careful. This is the joy of working on vintage TVs. We'll get it sorted out. I thought I could start doing a little work with parts I had on hand, but I very quickly found out that no, I don't have all of what I need. Because several of these, this guy, are 1,000 volt caps. And this one back here, I believe, is a 1,600 volt cap. And that's a 0.33 microfarad. I don't have any of those on hand, so for sure I need to order up those. Now where it gets confusing is this power resistor, these Sprague Adams that were installed down here, and the big chunky power resistor on top, because those don't match what service info I do have. It's a little hard to read here, but let's get this oriented the same way. So some are minor, like here I have a paper wax cap there, they show a bumblebee. I think that's the across the line cap. There should be a safety cap, we'll deal with that. Mostly it lines up. Strange large coil there, power resistor, yep, 45 degree angle transformer, yep, big old capacitor, yep. What we're missing is they show a second large cap here. And I suspect somebody clipped it out, relocated a power resistor over here, and put the caps down here. But I'm not 100% sure, because it looks like they show a mounting band across it, just like this guy. But I don't see any obvious place where it would have mounted, unless maybe it was here. Where there used to be two big seleniums, huge ones they show here, and now I have two diodes that are pretty ancient, and somebody added a power strip. So all this area has been reworked. This appears to be all original, so that's one plus. I've replaced one capacitor so far that I felt comfortable and confident in replacing. Something else I need to figure out if it's original or not is... well, yeah, they added a capacitor on top too, I forgot about that. Or replaced one on top. I need to figure out, is this original or not? Kind of looks original, but that's not what they show in the SAMs. In the SAMs, they show it being here, underneath the chassis. That's filament dropper resistor, which, I think it's on, yeah. They give you a nice breakdown of the series strong filament. So here's the AC line, all the tube filaments. I'm going to add these up and do the math. I'm curious to see what it works out to. But they decided to use a 45 ohm resistor in series with all these. I think I'll add a thermistor, maybe re-engineer this. If I'm lucky, I can put a diode in there or a capacitor to dissipate power with a lot less heat. That's what that guy is. What I don't know is, well, that screw does look suspicious. These are the kinds of detective work, the clues you want to look for. So I figure, is that original or not? Sam's isn't perfect. Not only that, but when they do Sam's photo facts, they buy a set and they reverse engineer it. But there are production run changes, so it's entirely possible that some variations have this underneath the chassis, some on top. But look at this screw. There's a really long screw and nut that doesn't look quite like they would have done originally. Now, this work that has been done on this was done a long time ago. Well, by long, I mean years and years ago. Like, this has got to be a new cap, but I'm thinking this work was done like 30 plus years ago. These diodes are pretty ancient, crusty kind of diode down in there. So that makes it a little bit tougher because the repairs are so old now, they look old. So some of it's hard to distinguish. But when you see fasteners, connectors, terminal strips that don't match the rest of the set, that's a pretty good red flag. Now, that being said, rather than this guy gets hot, so it actually would be better to have it up here than down below, or at least mounted to the chassis to make it a heat sink. But we'll dig into that more. So having tubes directly on the AC line, series strung, certainly became more and more common as you go into the 50s and the 60s. But it's nice to add a little soft start. When those tube filaments are cold, you turn on the set, there's a surge of power. That power resistor will help somewhat limit it, but a thermistor does a lot better job. But it's a little bit more expensive, so they didn't. There are a few other interesting things about this, I think. So we have a circuit breaker up here. I was wondering what this was at first. So this doesn't have a fusible resistor per se, which is really common for sets from this era. Really hard to read the schematic, unfortunately, but in here they do have a 7.5 ohm resistor, but they have a separate circuit breaker. I haven't located that yet. I wanted to see, is it a fusible resistor or is it just a power resistor? So I will do my best. I need to figure out, is this original? Was there originally another big multi-section electrolytic down here? If so, where exactly was it mounted? Should this power resistor be here? Because I don't want to mount a cap right next to a power resistor. I also need to replace this whole thing, this gigantic cap, which is 4 caps inside of a cardboard tube. So why did they use a cardboard tube? Because this is a hot chassis. So we have 5 leads coming out, even though there's 4 capacitors, because one of them is common negative for all of these. So I need to engineer a solution for this and get rid of these 2 caps, and I'll try to make it look somewhat like the original. May have to get a little bit creative with fabricating something with a tube and mounting them somewhere. No, I will very likely not be using an adapter cap in this because it's just not suited for it. Then there's the rest of the set, which I haven't looked at yet. But that looks to be a little more conventional. So that's, as I mentioned earlier, I have to pull out the whole assembly with the tuner and the board. I'll probably leave the board attached to the chassis sub-assembly, which means I don't have to remove all the wires going to it. But it also means I need to clear the decks to get that out, or it's just going to take up some space. But that doesn't have exotic parts, doesn't have 1600 volt caps and giant power resistors. It just has a few paper caps. But I do want to check it because some of them are mounted vertically and some horizontally, and you want to make sure you order the right type of cap so it will fit. So I will certainly take some photos and review it and try to match it up to this. So that's the bottom chassis we looked at. Here's a look at the top board. So we have a bunch, a little hard to read, but we have a bunch of tubes, a bunch of carbon comp resistors, but not too many caps. You kind of make one out here. It's a vertically mounted cap. It looks like the stripe is going up on it. But there aren't that many. Maybe half a dozen paper caps, if that. There's another one. And part of the reason, well actually a big reason for that, is because it has cup plates, which are diagrammed on this. I haven't looked close enough to see if any of these are the same as predicted, for which there are reproduction ones made, but we have 1, 2, 3, 4, 5, 6, 7, 8 of them in total. So I need to make a decision. Now, something I can't buy modern reproductions of these is, do I want to make them, or do I want to go with them as is and hope they're good enough for the testament place as best I can? Sometimes you can. Here's a great example. 3 capacitors and 1 resistor. One leg of the resistor goes to this pin, the other leg of the resistor goes to 2 caps. So there's no way to check that resistor value without busting the thing open. Similarly, I can't check the capacitor values because, well, these 2 I can get at one end of the cap, the other end goes to this resistor. So I can't check for leakage because that resistor is going to interfere with my measurement. But I can't check the value very accurately either. Same with this guy, because it has a cap and then a resistor in parallel with it. So it's often you can't test these to see if they're good or not. So it kind of comes down to do what you can, turn on the set. Does it work well enough? If so, okay, maybe call it done. Otherwise, yeah, have at it. The other problem with reproducing those is you don't know exactly what the characteristics are of the parts that were inside of those cup plates. You know, are those ceramic caps? Are those some type of plastic film caps? What's dielectric constant? What's the voltage rating? You just do the best you can. You can use the highest quality parts and think you're right, but if those were, say it's a certain type of ceramic cap that drifts in temperature and they put another part, so say a resistor that drifts the other way, and they're meant to work together, you can mess things up by just blindly replacing parts. So I'll probably just go with them for now, because the set isn't that old. We're talking 1960. It's old, but it's not ancient. And see how it goes. Makes me a little uncomfortable with so many questions. It'd be nice to find an original Sylvania service manual, but that's very unlikely, so I'll do the best I can. Now we're cooking with gas. Looked in riders and found reprints of the Sylvania preliminary factory service info. If you're wondering why I didn't look in riders earlier, well, riders stopped publishing around 5960, and I didn't think they'd be in here. But starting in volume 24, they do talk about this chassis. Now mine is probably a little bit later than this, and they do say it's preliminary in several places on this. But they did use this chassis in a bunch of models over several years, so I need to find out what variation I have. So they mentions chassis 1-537-5, There's also probably a -1, -2, -3, -4, -5, and so on. I have yet to find a chassis indicator on the chassis or inside the cabinet. It would really help if I could, because they made production run changes, and I don't want to get tripped up by them. But just looking at this parts diagram, one, it's really clear, easy to read, black and white, should print out very nicely. It also looks like what I'm looking at, aside from the modifications. So there's those two caps, the selenium, the angled transformer, and so on. So this definitely looks very promising. And on the top side, no filament dropper, no cap mounted up there, so I think all that stuff was added. And here's the other one, a circuit board. I like when I do the x-ray diagram so you can see the traces, but also the part outlines. And these are pretty good quality scans. Now some of it's not so great, so they do have little insets of scope waveforms. Unlike that SAMS we were looking at that I printed out, this is not the greatest, because this was scanned black and white, whereas the SAMS was scanned grayscale. This is why it doesn't print out so great on a black and white printer, but when you look at it on your computer, or if you have a nice color printer or something, generally these look pretty good. Gets kind of funky in some areas, but yeah. Such is life when you rely on scans rather than the original paperwork. Oh yeah, nice clear schematic. Good job, Sylvania. Now we're going to get that power supply a little bit more than I was talking about earlier. So there are a number of protection elements we've got on this. So hot chassis, one side going to, one side of this is the AC input, so one is going to ground. I do have a little filter choke on here. We've got a cap going across. We want to put a safety cap in there. Their fuse was fusible wire. It's just 24 gauge wire, a little strand of it. Idea being if this side had a dead short or something, that little bit of wire would burn out. It's like a fuse without any glass around it. It's just a thin piece of wire. Looks like they have another one on this side of the switch too. And there's that 47 ohm 15 watt resistor I was talking about earlier that I thought at first, well, I think the SAMS says 4.7, but this says 47. 4.7 will make a lot more sense. This is going to a voltage doubler to supply the B plus for the set. And why would you want to waste so much power on a 47 ohm resistor up front? So, yeah, I know it's factory service info, but I'm gonna hunt that down inside the chassis and see what's actually in there. I find it hard to believe they would want to burn up that much power right at the input. But you want to have something there, otherwise when this turns on cold and these diodes conduct, it puts a lot of strain on that cap. They have scope waveforms throughout the schematic too. This is one of the best schematics I've seen for a vintage TV. nice and big and clear and easy to read. But as you can see, I have a 21 CQP4 to 17 BWP4, so we gotta try to pin this down to exactly the variation that I have. They're tabletop models. Keep going. So I did see, this is in volume 24. I think it's in volumes 24, 25, 26, and maybe 27, which is the last. Yeah, it's the last volume. Oh, hang on. This is looking juicier. But that looks just like mine, but I think I have a 27C529, not a 626. Maybe this doesn't have the pop-up tuner. It's got to be a minor thing. And I don't have a 5BR8. I found in mine, what did I find? A 5AT8, I think, which is very similar. And a 4BQ7. Oh, I'm sorry, that's the sound. I'm getting getting my tubes mixed up. No, that does match. It's the tuner. They used a number of different tuners, whether you had UHF or not, and different tube lineups. All this seems to match what I have. So let's scroll down to see if they have a schematic and see what picture tube they show in it. It looks like the latching tuner mechanism I have. Just a quick glance. There's that top circuit board. Nice. I like how they broke out the control wiring here. And there's a couplate diagrams alongside. Lovely. So this all looks, so there's that. Oh, interesting. Huh. Well, the mystery deepens. So this, they do just show one cap here. They don't have the second one here, and they do have a power resistor. Aha. I want to know what tube's on there. Does it have a 10? Is it the horizontal oscillator tube or the vertical oscillator tube? 10DE7. That's what I've got on mine. Ah, and they do show a cap on top. All right. This is looking much closer to what I actually have. Do they? And there we go. Model 21C529. Oh yeah, not a touchscreen. At work I have touchscreen, but I'm at home right now. That's cool. You can see all the cabinet variations. So it looks like they have two that instead of having a tray down here, they have different types of drawers. Yeah. I'm glad I got the one I got, because looks like there's three variations with drawers and one with a shelf. I think the shelf is a little bit sleeker, cleaner look. I wonder if I suppose these open for storage, which could be handy too. On these have little tapered Danish modern legs, where it just has a squared off leg. So this is a supplement. So this is not continuation of what we said earlier. I mean, this better have the exact details that match mine. But that means I have to look at the other previous info and then pay attention to the differences in this info. So there's the speakers, as one of you pointed out. They are 4x8, they're not 5x9. But they do have two different model numbers, which is curious. I'm not sure why, but they are not identical speakers. Probably one of them has that whizzer cone in the middle, but I can't say for sure unless I take them out. But they are just wired together. There's a difference in one of the, it's what, the video detector, third eye F amp. They use a diode for that. Whew, man, I really got to figure out what chassis I have. But that's cool. Much better than the Sam's. Okay, now I ventured into a different one, I think. I got to pour through this because now we're looking at, there are so many variations of this body chassis, so now we're back to two caps. And no cap on top. But it does have the 10DE7. I've got to find a number on that chassis and figure out what exactly do I have, or I'm going to be going nuts. And there's our 21 CQP4. So, yes, 524, comma 1, 2, 3, 4, 5, 6. Which of those 6 variations do I have? That's what I want to know. Well, I gotta say the Sylvania engineers did a pretty good job with their filament dropper. So here's the whole tube lineup with the exact voltage. So yeah, 5ATA doesn't have a 5-volt filament, it's 4.7. 6CG7 is not a 6-volt filament, it's 6.3. These are all 0.6 amps. If you add up all of that, you get 89.4 volts, and that's why you can't just run that directly off the line. If we take 117 volts AC, that was the typical voltage at people's outlets in their home, and subtract 89.4, we get 27.6 volts. That's the difference. If we divide 27.6 by 0.6 amps, which is the current running through all these, we get 46 ohms. So assuming you have 117 volts going in, you want to have a filament dropper of 46 ohms, which I think they have 45 ohms on the schematic. So typically what I do, because we have more like 125 around here, is I want to bump that up a little bit, or keep it at 45, 46, and add a thermistor in series, which adds a few ohms to that and provides a soft start. So if you use something like a CL90, it's 120 ohms cold, and with 0.6 amps running through it, it'll be about 5 ohms when it's fully heated up. So that would make up approximately the difference between with the higher line voltage. So I'll probably be okay with that. But there is another way to do this. And this falls into that ballpark. I'll have to pull out another spreadsheet that has some calculations on it. If you replace that 45, 46 ohm resistor with a diode, I think we'll come pretty darn close to hitting this, and then there'll be no waste heat generated. Here's my handy spreadsheet I found online a while ago. Created back in 2002 by Paul Stenning. Must be in Europe or the UK because it has 240 volts, 50 hertz. So this is a calculator where you can plug in those parameters we just talked about, and they'll show you if you want to use a pure resistor, or try using a resistor with diode, or try using a resistor with a capacitor to drop that filament down. So we need to change these a little bit. So let's go with 125, and we're going to change this to 60 hertz. And our heater voltage is 89.4, and our heater current is 0.6. Okay, so with the higher supply voltage, this bumps up to almost 60 ohms, kicking out a whopping 21.5 watts. I would use a 50 watt resistor for that. It's a good rule of thumb to double the wattage, and it should probably be mounted to a heatsink or a chassis to dissipate the heat. It's a lot of waste heat. Now the next one, dropper resistor with diode. So that would be just a single half-wave diode in series with the tube filaments with no dropper resistor, or a little bit of a resistor. Because if you don't use any resistor in series with the diode, and when all the tube filaments are cold and you turn the set on, cold tube filaments have a much lower resistance. It's going to be a big surge current. You can blow out the diode. You really should put at least a little resistance, we'll say 1 ohm, in series with the diode, in series with all the tubes. But we have negative 2 ohms and negative 0.6 watts, meaning that these numbers aren't going to quite work out. Now if our heater voltage instead was say 85, then we can do it. That's right about where the threshold is at, around 85, 86 volts. You can do it. 87, still do it. 88, yeah, but right where I want to be at 89, we get negative nonsense values. Now, realistically, what does that mean? what if let's drop it back to 88. What if I put a 1 ohm resistor in there and used a diode? Would it work? Yeah, it would. The tubes would just run slightly leaner. I mean, we're talking about a 1 volt difference. And my line voltage does fluctuate. It will be a little bit lower in the summer, and everybody has the air conditioning's running. So I could do this. It's right at the edge of being feasible or not. Because if I do this, hey, I have a 1 ohm resistor kicking out 0.2 watts. It's a lot better than 62 ohms at 22 watts or 60 ohms at 20 watts, whatever it might come out to be. So I think that's a good idea. But I'd also like to put a thermistor in series with that too, which is also going to drop a little bit, which make the tubes run even a little bit leaner. So what is the downside to running a tube a little bit lean? Well, if it was too lean, like say it was only half the current it's supposed to have, it's not going to work properly. What if it's 10% lean? In some cases, it can prolong the life of the tube. But when you kind of get into a gray area where it's running a little too lean, it can have some problems where you could potentially damage the tube structure because that gets a little complicated. I've seen this mostly applied to when you're talking about like transmitting tubes and things like that, where you get cathode poisoning or material gets deposited on elements inside the tube where they're not supposed to be because things aren't running as hot as they should be. For consumer grade, low power tubes, I don't think this would really be an issue if, say, we're running at 5 or 10% lean. In the picture tube, perhaps it would prolong the life a little bit, actually, so it might not be such a bad thing. But we're really just talking about a few percent. I think we can do it. Now, the final option is use a dropper capacitor. So we could use, say, a 22 microfarad non-polarized AC-rated capacitor in series instead of a diode, instead of a resistor. But just like with the diode, you should put some surge current limiting. And with this calculation, they're talking about 17 ohms at 6 watts. So this is actually the lowest waste power solution. I'm not doing this to be green and save energy. I'm doing it to reduce heat inside the set. And because heat is, of course, the death of everything, and that they have that dropper resistor right by the filter caps on the power supply. So if we can reduce heat in that area, that's a good thing. So I think we should go with that. It also means I don't have to order an expensive 50-watt chassis mount resistor and drill holes and mount it on there. I just have to put in a little baby diode. And not a bad idea to put 2 diodes in series, because diodes typically fail shorted, so if one shorts, the other one can keep doing its job. Yes, it will drop even more voltage, but it's not a bad trade-off. Also not a bad idea to put a reverse bias diode on the other side of the main diode, so if the main diode shorts out, it'll go directly to ground and blow the fuse to protect it. So we'll talk about that more when we get into it. I just wanted to show you that yes, this is possible. It's a good power savings and cost savings and run cleaner. Wanted to do it back then because I didn't have good beefy power diodes like we have now. Otherwise, I suspect they would have done it.